Okay, so through the semester, you're going to hear me and the tutors talking about sketches. And we don't mean drawing with a piece of paper and a pencil, although that's very useful in your creative process, of course. We're talking about using code in a way that's closer to a form of sketching than like a traditional computer program where everything has to be planned out and work perfectly. We're trying to think of code as something quick and sketchy that lets you get quick results back and learn quickly rather than something that takes years and years of expertise to get really even familiar with. So we want to come to code with the attitude of sketching in code. Let's think a bit more about what that means. I'm going to start with a video and I'll switch into the video. This is from an artist called Zachary Lieberman. He was actually part of that project called the iWriter that I mentioned in the previous section. He says, a lot of what I do is ask those what if questions. What would it look like for a line to uncurl itself? Then you have to write the software to see that answer. Let's watch that video and listen to yourself when he talks about this idea of what if questions.
I'm trying to bring joy to people, make people smile. I'm trying to create strange, unique moments for people. My background is in fine arts, and I studied painting and printmaking, and I'd always loved animation. I love this idea of animation as bringing something to life, and this idea that you could write code and breathe life into things for me was really fascinating. A lot of the projects that I do involve gesture, involve drawing. What does it mean to make a mark? There's something really kind of fundamentally important with putting a line down on a piece of paper. That's like saying, I'm here. And a lot of what I do is ask those what if questions. What would it look like for a line to uncurl itself? Then you have to write the software to see that answer. And I think we need a culture of poems. I use the term poetic computation to describe what we do. For me, poetry is the right words in the right order. Code is also the right words in the right order. It is.
Code is like poetry. Poetry is the right words in the right order, and code is also the right words in the right order. But he talks about these what if questions. What if a line could uncurl itself? And when you ask yourself a question like that and find yourself thinking, I wonder what that would be like, that might be a good starting point for a creative coding exploration. And you saw in the video how he could draw one of these lines and it would uncurl itself and then curl itself back up again. A lot of what we'll do in the semester is ask those what if questions. Here's a simple little example that I made a couple of years ago just to try and illustrate this concept. I said in the lecture off the top of my head, what would it be like to draw with clouds? And then I thought, you know, that would actually be a really good example to code up. So I made an example where you could sort of draw with clouds. So in this one, it's called Cloudbuster. You can click and draw. And you get these kind of lines that initially basically follow where you've drawn. But over time, they kind of drift and get blown along sideways and they become more cloud-like. And you can actually take the wind here as a sort of an eraser tool and by drawing over the clouds here, draw away the little puffs, you can blow them away. So it's a kind of like a drawing and an erasing tool, but there's more going on. It's got this cloud-like quality as well. That's an example of asking and answering a what-if question for yourself with code. Hopefully, as we go through this semester, you'll think of some of those what-if questions to ask yourself. Casey Reese again, who we mentioned in the last part, says, working directly with code leads to a deeper understanding of the conceptual and the creative potential of the medium. What he's saying here is advocating really that if we want to use code as a creative medium, we need to code. It's not enough to copy and paste code from the web and put it into your project and then press play. You've actually got to code yourself. So in the semester, we will have a lot of hands-on activities in the tutorials where you actually code yourself. That's the best way to learn. This idea of sketching in code that I talked about really involves artists and designers producing sketches in code. And this is familiar in many art and design practices. We often produce sketches before making the final product. If you're designing a game, you might do a simple storyboard of how the game's going to unfold. Or in the case of interaction design, you might draw a little sketch of the system diagram of the service architecture perhaps of who uses the service, what the touch points are, and so on. In P5GS, we take this sort of metaphor and think of the idea of a software sketchbook. So a way of making it really easy to explore and refine different ideas in a short period of time. Sketching doesn't always have to be end product focused. It can simply be exploring the aesthetics of the medium. So I really encourage you when you're learning coding to try these little experiments. Save a version, try something else. Doesn't work, no worries, go back to the first one. Keep going, save another version. Save early and often is the best way. Sort of reinforcing that point, just as it's not possible to learn to cook without cooking, it's of course not possible to learn how to program without programming. So if you're going to take this unit and do well, you really need to get that hands-on practice with coding, with actually producing code that doesn't always run, that often has bugs, which can be incredibly frustrating, but that's really the only way to learn it. So you will encounter problems through the semester. Keep going. The biggest success factor is persistence when you're learning coding. It's not smarts, it's persistence. So be persistent, keep going, and you'll get there. Right, to end this section, I want to talk quickly about one of the creative briefs from assignment 1, and it's called active drawing. And this image actually is of a physical sculpture which kind of sums up the idea. You can see here this big inflatable ball has all of these little spiky protrusions on it. They're actually little charcoal pencils stuck to the outside of the ball. And when gallery visitors go into this exhibition and they hit the ball, it bounces against the sides of the gallery and leaves these marks around the gallery. In some sense, the people are making those marks, but it's not all up to them. It's also how the ball bounces around unpredictably. So the nature of the marks that are produced are not fully down to the person, and they're also not fully down to the ball, to the interface, if you like. Some mixture of the two. Some control is with the person, some control is with that unpredictable bouncing ball. I think this is an interesting idea to begin with and to think about in the context of creative coding and interaction design and game design. And this is a model, quite an old model of interaction from an author, Don Norman, and it's the 7 stages of interaction. In some ways it's a little old-fashioned, but it's a good place for us to start. Norman talks about when we're acting in the world, we first, well, it's hard to say which come first, but let's say we first have a goal that we want to achieve, and from that we form an intention to act. So maybe I want toast in the morning, right? I get up, I'm hungry for toast, I have the intention to make some toast. Then I sort of formulate a sequence of actions. Well, the first thing I've got to do is put the toast into the toaster. I do that, so I put the toast into the toaster and then press the toast down, and then something happens in the world, right? So maybe my toast, after a while, starts to have some black smoke coming out the top of it. Something's happening in the world, and I see, oh, my toast might be a little overcooked. So I'm perceiving the state of the world. And then I'm interpreting that perception. Yeah, this toast is overcooked. And then I'm sort of evaluating those interpretations, saying, oh, okay, well, then I need to do something, which leads to a new goal. I better get that toast out of the toaster. Right, so there's this sort of very simple loop-like model or way of thinking about how we're interacting with the world all the time in this kind of feedback loop. And it's a sort of it's a useful way to think about interaction with a computer, because we have a similar sort of a structure here. We have, that we might click and drag with a mouse. to control something running on the computer. So we're performing an action, and then we get feedback from the computer that tells us what's happened there. So, we can see on the screen there's a little cursor representation that's moving around as we move. And when we release our finger, that stops drawing. So this kind of loop of acting and getting feedback from the computer is kind of a useful way to think about it. But if I draw your mind back to that picture of the active ball bouncing around the gallery, as programmers, as creative coders, one thing we can do is think about what is the mapping between the action that the user takes and the feedback, what happens on the screen. It doesn't have to be one-to-one. It doesn't have to be like a direct line that traces exactly what the user did. We already have lots of software tools that do that. So there's maybe a possibility for us to explore more active kinds of drawing. And what I mean by that, I sort of try to explain with this simple diagram where we have something that's more direct. So think Microsoft Paint, right? There's just a one-to-one mapping between how I move my mouse and what gets drawn on the screen. Of course, there's still some level of interpretation there, but it's a fairly direct mapping. Maybe somewhere in between, there's something that's a little bit more active where I might have a command on my drawing tool that makes the line more angular. So as I draw, I don't get a straight interpretation, straight mapping of that line, but something that kind of follows it in an angular way. And then at the other kind of end here, something that's really active, maybe I have a computer program that lets me interactively draw vines with tendrils and flowers coming off them. So as I draw the line, tendrils and flowers kind of magically sprout off the line as I draw. So that would be more active. There's some more role for the software is adding into that final image in addition to the actions that the user takes. So when we talk about an active drawing program, we're not thinking about sort of replicating Microsoft Paint, even though that might be a very good programming task. What we're actually thinking about is how could a drawing program be more creative? How could it take a more active role in that process of drawing? So I want you to think about that and puzzle over that a little for yourself as you go through the first couple of tutorials. And your tutor will talk about that more with you as well. So that leads to the question for this section. How is control shared between the code and the person in each of these examples? What's the feedback that the person's getting? What's the mapping from the person's actions to what the code does? Are some more active? Are some more direct? Are those interpretations and layerings of meaning that the code provides enriching, amplifying, and extending our capacities? Have a comment in the Slack on each of those and tell me what you think. In the last section, we'll dive into P5.js for a very quick demo of sketching in P5.js and what that means in practical terms.